Hello, so continuing on weekly contest 337, the last problem, which is smallest missing non-negative integer after operations. So what is this problem about? So we get an array of numbers and we get a value, and then in one operation you can either add or subtract value from any elements of that array. So for example, we get this array 1, 2, 3 and a value of 2, and you can choose to either add or subtract value from any position. And so for example, let's take the first position. We can subtract 2 from the first position, 1, so we get -2. You could choose to add 2, for example, to this one, that will give you 4. You get the idea, right? And there is this concept of max, which is minimum excluded in an array, where it's just the smallest missing non-negative integer, right? So for example, if you take a look at this -1, 2, 3, the smallest missing integer, non-negative integer, is 0, right? If you take 1, 0, 3, the smallest missing one is 2. So basically you start counting from 0, 0, 1, 2, 3, 4, and then if any of these, the first one that is missing, that's called the mix, okay? And the goal of this problem is to apply this operation any number of times such that we get the maximum mix in the array after applying this operation any number of times. No limit to the number of times you can apply it to. You can apply it. The only thing we want is to get the maximum mix, okay? So for example, if we take a look at this array, what we can do is for the first value, we can add value 2 times. So we add 5 2 times, we end up with 0. Then we can, this one 7 here, we can subtract 5 once to get 2. That way we have 0, 1, and 2. And then for this 13 here, we can also subtract 5 twice. So we subtract 10, we end up with 3. So that way we have 0, 1, 2, 3. And then what about 4? The problem with 4 is that if we try to subtract 5 from 6, we'll get 2, so that doesn't work. If we try to add 5, that's 10, doesn't work either. For 8, if we try to subtract 5, that gives us 3, so that doesn't work. Adding also doesn't work, okay? So that means basically with these we can't change them to make them 4, and so the max here, no matter how many operations we add, we can't get 4, and so we have we return 4 as the max, right? So that's sort of the idea. Now how do we tackle it? Okay, so how do we tackle this? Well, one observation you should make is if any number, let's call it a, modulo the value that we get, right, is equal to some value x, right? Then if this is the case, then you can make a become x with a certain number of operations, because our operations are either adding value or subtracting value. If modulo value is equal to x, that means you could do x either plus or minus value any number of times and you will get x. That's literally what it means with modulo. Because let's take an example. Let's take, for example, 6. If 6 modulo 5 is equal to 1. Right? And so you can see here, 6 minus 5, you can just subtract value once and you get 1. Okay? Minus 10 modulo 5 is equal to 0. And this is, you could, minus 10, you can just add value 2 times and then you will get 0. Right? Let's go again with 7 modulo 5, that's 2. Now we could just do 7 minus 5 to get 2. This is just to give you examples, but this rule should apply regardless, right? This is what modular arithmetic literally means, okay? Okay, so from this observation, what can we do? Well, from this here, that means that for any value a, right, if you are looking for, so with max, what are we looking for? We will go from 1 and then make sure, check if it's there, check if it's 2 is there, check if 3 is there, check if 4 is there. So we'll go in increasing order by 1 each time, all the way until 10 to the power of 5. And anytime we find that it's not in the array, we stop, right? Okay, and so let's just consider these values to be the x's. Okay, so what are we interested in? For every x, we are just interested in if x modulo, if any value of a modulo value is equal to that x value. That's what we are interested in. So for every value x here, what we are interested in is whether there was a value in the array that a modulo value will equal to that x, right? We don't need the exact a to be equal. We just need a modulo value to be equal to x, for that number to be counted as there, because we can just take the number, add or subtract value any number of times, and get the value of x we look for. Okay, so what does this mean? Well, this means what we are interested in is just knowing whether this exists or not. What's the easiest way to find if this exists or not? Let's just pre-process and put it in a map. That would make it an O of 1 operation. So how would that look like? Well, what that will look like is we'll just create a map here. Let's call it frequency. And for every a value, right, we will just add how many times did we see that a modulo value. So what value in our case here is equal to 5. So first, the frequency is going to be 1 modulo 5, that's just 1. So 1 occurred once. Minus 10 modulo 5, that's 0. That means 0 occurred once. 7 modulo 5, that's 2, occurred once. Let's just push this down a little bit here. And so here 2 occurred once. This is x. And then if we look at 13 modulo 5, that's 3. 3 occurred once. 6 modulo 5 is 1. So 1 occurred 2 times. 8 modulo 5, that's 3. So 3 occurred 2 times. Okay. So now with this frequency, it's easy for us to check if the value, a modulo value, so this is a modulo value, and this is how many times it occurs. So we can just check. So is 1 there? Yes. And so once it's there, we want to subtract by 1, so that basically, let's say later on for 6, right? 6 modulo 5 is in the array. So for 6, x equal to 6, we want to say yes, it's there, because 6 modulo value is equal to 1, and that's equal to a modulo value, right? Because we look for x and x modulo value. Why is that? Because can you get 6 out of 1? Yes. We could just subtract value once, and then you get 6 minus 5 equal to 1, right? And so here we look for x modulo value. So here we look for if frequency of x modulo value exists in the frequency still, which means basically we check if it's bigger than 0, right? And so now we check if so we did that. We check if 2 is in there. 2 is there, and so we use it and we remove it. We check if 3 is in there. So x basically every time we just increment it. Is 3 there? Yes. So we subtract 1. Is 4 there? It's not. Okay, 4 modulo 5 is still 4, and 4 is not there, so we stop and we return 4. So that's sort of the idea here. Now, just to give you more insight, just to make sure that this really clicks, let's do it on another example. Let's do 1 minus 10, 7, 13, so same array, but the value is now 7. Okay, so in this case, what's our frequency map? So 1 modulo 7 is 1. Minus 10 modulo 7, well, we can add 7 once, so that would be minus 3. We add 7 again, that would be 4, right? So we have 4. And then 7, that's just 0, so we have 0 once. 13, well, 13 modulo 7, that's just that's just 13 minus 7, so that's 6, right? Yeah, so that's 6. So we have 6 once, and now for 6, again 6, we have 6 twice, right? So let's just mark it as twice. And now we have 8. 8 is just 1, so we have 1 again, so we have 1 twice, okay? So we can remove this, and we have 1 twice, okay? Okay, so now we start with the x's. Is 1 there? Yes. So we subtract 1. Is 2 there? No, it's not. So we stop already and we return 2. Okay, so that's sort of the idea. And then here, let's say if we had 2, just for the sake of this, let's say if we had maybe 2 somewhere here. So we have 2, 1. So we'll find 2. Okay, good. We set this to 0. 3 is 3 there. It's not, so we return 3. Let's say if 3 was there, just to make this more interesting. So we have 0. Let's say if 3 was here. We try 4. 4 is there, so we are good. We try 5. 5 is not there, so we return 5. You get the idea. And even if we, let's say, got to 8, right, we'll do 8 modulo 7, which is 1. 1 would be there. Let's say 5 and 6 were there, and 7. Then we will just say 8 modulo 7 is equal to 1, and 1 is there, so we are good. We go to 9. And that's why we do modulo here, because we have 1 twice, and so 8, we could just do 8 minus 7, and we get 1. And so it can actually be, we can get from 8, we can get to, we can use 1, right? Or we could do also 1 plus 8 plus 7 to get 8. So 1 plus value to get 8, right? So that's why we do both x modulo value and a modulo value, because if those are equal, then we can get from a to x using any number of plus value or minus value. Yeah, so that's pretty much the idea here. Just using this frequency map to keep track of a modulo value. And then for x, we just go from 1 and keep going up as long as we find it. Until we don't find it, we just return it. Okay. And that's pretty much it. So let's implement it and make sure it passes our test cases. Okay, so to implement this, what we need first is we need our frequency map. And so that would be just a collection of default dict of 1. You could also use a counter if you wish to. And initially it's int, so that if the value is missing, it starts as 0, right? And then we'll go through the array. So for a, let's just name this a to be easier to write. What we want is we want to record if a modulo value is there, right? So we are comparing modulo values. Okay, and then we are going to start our x from 0, because we want to start from 0. Sorry, in the example earlier, I didn't try 0, but we should start from 0. That's what the problem asks us to do, is to non-negative integer, so starting from 0. So here, while the value exists, and by exists we mean just x modulo value is there, right? Not just x modulo value. This is, for example, the case of 8, and the value is 7. We want to check if 1 is there, right? We normalize everything to modulo value. That's the idea here. So if it exists, as long as it exists, we want to keep going. So we want to say this, we taken this, so we subtract from it, and then we increment x. Now, if ever this fails and we exit the while loop, that means we found an x value that is normalized with modulo is not in the array, so we can just return it, because that means it's missing. That means there is no number of adding value or subtracting value that will get us this x, right? So if we run this, submit, it passes fine. Yeah, so that's sort of the idea here. It's just normalizing with modulo value. Yeah, so that's pretty much it. Please like and subscribe, and see you on the next one. Bye.